everyone, this is Mr. Fugay. I hope you're having a good day today. This video, we're going to talk about the introduction to one of the most important concepts in the geometry course, and that is congruence. So prior to this video, I hope you've taken some time to look at the difference and why in math we would say that two things are equal versus two things that are congruent. This video is going to really dive in much deeper into that congruence ideas and why we classify shapes as congruent and what exactly that means. So let's jump right into it. Right away, I have two figures here. The definition of two figures, which could be triangles, which is what we're primarily going to focus on, or any other shape, two identical shapes that have all corresponding sides and all corresponding angles equal in measure. Now, in the next example below, we'll talk about what the word corresponding means. But I want to give you a visual here when we look at this figure here. So we have this blue quadrilateral over here, A, B, C, D, and then we have a green quadrilateral. In order for two shapes to be congruent, it basically means they have to be the exact same, a copy-paste of one another, a clone of each other, whatever synonym works for you here. So for example, if I take this blue shape, I can move its outline over here. What I can do is if I flip this and rotate it around, I can show you by flipping it and then by rotating it that in fact the green shape and the blue shape are exactly the same. They're the exact same measures. So, and more specifically, we could go and look at each individual component of this shape, the four angles and the four sides, and show that I have four pairs of angles. For example, angle D and angle G, they are the same angle because in the old outline that was angle D, and you've seen through that transformation I just showed you that it ends up being the same. So this video is really going to just talk about how we can label this and communicate when we know two shapes are indeed congruent. So let's start with our labeling, all right? So first off, to remind you, the congruent symbol is going to be an equal sign with this, what we call the tilde above it, all right? That little squiggly sign, whatever you want to call it, that means congruent. So when I talk about two shapes being congruent, for example, these two triangles here, triangle ABC and triangle FED are considered congruent. Now on this one, yes, I could trace it out and show you that they're the same, but the markings are what's going to tell me what's congruent here. For example, angle A and angle F both have a single arc marking, congruence mark on it, which tells me that they are equal. And that means that therefore they're also congruent. So angle A is congruent to angle F. And we can do the same for our other sides. Angle B and angle E both have a double congruence mark on them that tells me that those angles are going to also be equal. And finally, let's get my green pen out for this last one. Angle C and angle D are going to be congruent as well. Now, I have this color-coded to really emphasize the importance of the order here, okay? So you have to list the corresponding vertices in order for this statement to be true. So notice I have A and F both in the first position, B and E in the second position, C and D in the last position. Now, this isn't the only acceptable triangle congruent statement. So another acceptable way that I could write this would be, if my pen will let me work here, sorry about that, is I could say, for example, triangle, what if I wanted to call it BCA now? The other name of the triangle I would have to put in the same exact order. That means since B and E are considered corresponding angles, since B was first, E must come first here. The next letter I have is C. Since angle C and angle D are corresponding, D would be my next letter. And finally, since angle A and angle F are corresponding, this is how I would write it. So a second acceptable triangle congruent statement would be triangle BCA and triangle EDF. So now I want you to try. Looking at this one, if I now call this, let's actually call it CBA, okay? Actually, let's do CAB. I'm just thinking on the fly here, all right? What would the name of the other triangle have to be called to show that it's congruent? Pause if you want. Since C and D are corresponding, C and D will be first. Since A and F are corresponding, F would come second. Since B and E are corresponding, E would go last. Now, there's all the other varieties of combinations of this that you can, but the most important thing to remember from this is corresponding vertices must be in the same order. Now, we also need to list out our sides. So we'll notice here, for example, segment AB, okay? Segment AB is going to end up being congruent to segment FE. I'll try to keep these color-coded for you here, okay? So those are considered congruent to each other. Cool. Well, then we also have segment AC here, which is listed with the double congruence mark. So if we have segment A and then C is green, what would be the corresponding side on the other shape? Well, it would be FD. So FD like that. And I'll come back and put the congruence mark at the end. And then for the last one, we have BC, which is over here on the left. So BC, and that's going to be congruent to ED. So notice, again, I'm using the colors here to really emphasize the relationship between these corresponding angles and then these corresponding sides. Let's go ahead and put the segment symbol above all of these. And that would be a list here of all corresponding angles and all corresponding sides. So for the remainder of the video, we're going to go through 3 examples of how we can use this idea of congruence to help us, number 1, label congruent figures properly, and then B, to find missing measures, angles, and sides as we see fit. So here's our first example. For this first one, it says write a congruent statement for the triangles, identify all parts of congruent corresponding parts. So the first shape on the left here, I'm going to call it triangle JKL. And the order that I pick for the first statement is really not a big deal. The order for the second one is really important. What corresponds to J? Because that will need to be first in my next shape. That would be angle T. What corresponds to angle K? Well, angle S, because they both have the single congruence mark. And finally, angle L would correspond to angle R. Now, I want to remind you one more time that you could have picked a completely different order. As long as J and T are in the same position, as long as K and S are in the same position, and lastly, as long as L and R are going to be in the same position. Now, I would like you to pause this video now and identify our corresponding parts of this triangle. So there should be 3 corresponding angles listed and 3 corresponding sides listed. Go ahead and pause and try that out. Here's what I came up with for my 6 corresponding parts. So starting with angles, as I said again, since J and T are in the same position, they're congruent to one another. Since K and S are in the same position, they're congruent. And lastly, L and R. Now for these next ones, like for JK, those are the first 2 points listed. So the first 2 points listed here would have to correspond. So JK is congruent to TS. And we can use that same argument for KL being the last 2 and SR being the last 2. And then finally for JL, first and last, TR, first and last as well. Now we're going to use these corresponding parts to help us solve for missing parts in our next 2 examples. And so here we are. All right, so we have a triangle here, and I've now already provided for you the congruent statement. So that's going to help us immensely with some of these. So I'm going to go through the ones that are the congruent sign first, because we're looking for the corresponding name, the shape that we're looking for. So for example, in letter A, what is the corresponding angle to angle W? Well, since W is the middle angle listed in this statement, the corresponding in the other shape is going to be angle H. So angle H for that one. So if we look for letter B, okay, angle B is going to correspond with the first position here, so that's going to be angle P. All right. Now, if we think about segments instead, let's talk about segments. So if we have segment LP, LP is the third and the first point listed. So the third and the first point listed of my corresponding shape would be segment IB. And finally, for BW, BW is the first 2 points listed for our shape, and PH are the first 2 listed as well. Notice that when I'm doing this, I'm not even looking at the shape. Like, yeah, can we mark all of these on our shape? Absolutely, and we will be talking about that in a minute. But to me, the most important thing when we're working with congruent shapes is the congruence statement, which is why it's so crucial to get it correct. Now, to wrap this up, let's talk about the measures, so being equal. So I want to know what angle P is actually equal to. And when I look over here, I see that it's equal to 60 degrees. So I just directly look at it and identify it. For the next one, for angle L, we'll notice that nothing is listed here. So instead of being stuck, we're going to look at its corresponding angle in the other shape. Since L is in the last position, it corresponds with I. So we see that angle I is 50 degrees. Therefore, since L and I are congruent, L would have to also be 50 degrees. So I can even mark that on my diagram if I want. For LH, LH is the last two segments here, and if I look over here, LH is already listed as 11. So let me erase these circles here. So LH is just directly going to be 11, and if you'll notice here for HP, once again, HP is not listed, but since HP corresponds to BW, all right, just as we actually pointed out above here, then we can look at HP, or sorry, at BW, my apologies, and see that it's 10. Therefore, because they are corresponding parts, they both have to be equal. Therefore, HP is equal to 10. So for congruence problems, you need to give me the name of the corresponding part. For equals, I want the actual measure of what that shape is going to be. All right, it's time for our last example. So in this shape, we're looking at a quadrilateral. Notice once again, D and S correspond, E and P, F and Q, and then lastly 3, 4, 1, 2, 3, 4. I was trying to keep the underlines there the same. I think I messed the one up there previously. Let me erase that. There it is. So now I want you to pause this video and see if you can set up an equation to solve for X and then to solve for Y. Go ahead and pause now. So let's start with X. We'll see here that I have an X listed as 2X minus 4. Now that segment is segment QR. QR is the last two positions of my quadrilaterals, so its corresponding part would be FG. Notice over here that FG is equal to 12. So we just set these two equal, and now this allows me to solve for X. So we're going to get 2X equals at 16. Divide both sides by 2. My X here is going to equal 8. So X is equal to 8. And that's really important because in order to figure out the next part of our problem, we need to look at the angles. We see that we have a 6y plus x. That is angle Q. The corresponding angle for angle Q will be the angle in the third position of the other shape, which is angle F, which is 68. So my equation is 6y plus x equals 68. Now, because this has two variables, we run into a situation. Thankfully, since we know what x is equal to, I'm going to erase that x, and I'm going to put an 8 there. And now we can proceed to solving the problem. So we'll subtract 8 from both sides. We get 60, divide by 6. Y will equal 10 in this example. So that is congruence, and we're going to be diving in even more deeper into the congruence ideas. But for this video and for this lesson, really it's just important to focus on writing those congruent statements the correct way and being able to set up situations where you can solve for missing parts, segments, and angles of that triangle or any shape that's marked congruent. That's the video. Hope you guys have some good understanding with this, and feel free to go back and look at any of the other examples that we've done in this video again. And thank you for watching.